Welcome back to my Betaflight 4.3 configurator walkthrough. In this video series, I'm going through every single option in Betaflight configurator so you'll know what it does and how to set it up. This is a video series because it's a lot of content. This is video number 2 in the series. If you are looking for the series as a whole, there is a link to the playlist down in the video description. And if you stumbled upon this video for some reason, get what you need from this video, but then I highly encourage you to go back to video number 1 and start from scratch and just learn it all. In this video, we are going to go through the Ports tab. Let's get into it. In order to understand the Ports tab, let's take an example flight controller like, I don't know, my own JBF7 flight controller. And we're going to look at the wiring diagram for this flight controller. And there's stuff that you got to hook up to a flight controller that has to communicate with the flight controller. Stuff like the DJI video transmitter, which uses serial communication to send information about battery voltage, on-screen display, and other such things. Or like your receiver. Your receiver sends digital data to the flight controller that tells it what you're doing with your sticks. Or your video transmitter. Your video transmitter, yes, it sends video signals through the flight controller, and that's not a digital serial communication, but it also does SmartAudio, which is how the flight controller can tell the video transmitter what channel it should be on or what output power it should be on. The point is that there are various peripheral devices that we connect to our flight controller, and the flight controller needs an interface to communicate with those devices. And those interfaces are called UARTs, and you can see a list of the UARTs on this flight controller here in the Ports tab. Now, if we look on Wikipedia, we can see that UART stands for Universal Asynchronous Receiver Transmitter, and you can go read that Wikipedia page if you want to know more in depth. But the point is, a UART on a flight controller it's kind of like a USB port. It's something that you attach a peripheral to that the flight controller is going to communicate with. So here in the Ports tab, we see the UARTs that this flight controller has, and they are numbered 1, 2, 3, 4, 5, 6. They are usually, but not always, sequential. Some flight controllers might have a missing UART. They might go 1, 2, 4, 5, 6, or whatever. That's a decision made by the designer of the flight controller. Don't be surprised or think anything's wrong if you see one is missing. And for each of these UARTs, we are going to tell the flight controller what type of peripheral device is attached to that UART. And we're going to do that by adjusting these options here. Now, when we set up the flight controller, we're going to connect each peripheral to some UART TX and RX pads on the flight controller. So each UART has a TX and an RX pad associated with it. TX is for transmit, RX for receive. And you're going to see those denoted in wiring diagrams or in pin layouts as T2, R2, T1, R1. T2 is UART2 transmit. R1 is UART1 receive. So immediately the UART number that we're working with is designated by that number. And sometimes we'll see that these UARTs are accessed via plugs. In other words, they're sort of mapped by the board designer to a pin inside a plug. And other times we'll see that they are accessed via a solder pad. Here's the solder pad is R1, T1, T2, R2. And if we go down here, we can see T3, UART4, UART5, and so forth. The takeaway is that when you've finished building your quadcopter, you should have a mental list, or maybe even a physical list that you write down, of the UARTs that your flight controller has and what you have attached to that UART. And in fact, if you're starting a new build, it might be a good idea to make this list before you even start building so you can start thinking about where you're going to put all the wires to all the peripherals that you've got. For example, you may go, okay, I'm going to put my receiver here, my video transmitter here, and oh no, I need to put my GPS somewhere, but the flight controller is out of UARTs. And then you got to think about what you do. Better to find those things before you start building than in the middle of a build. So now we're going to go through the Ports tab and talk about the different things that you can put on each UART and how you configure the Ports tab to interface with those things. And the place I like to start is Serial RX. Serial RX refers to your receiver. That's the thing that you bind to your controller, and it receives your stick movements and communicates them to the flight controller. There are different kinds of receivers: FrSky, FlySky, Spectrum, Futaba, Crossfire, Tracer, Ghost, Express LRS. I'm just rattling these off because I wanted to ring a bell with you if you've got one of them. All of those are serial receivers, and you would indicate to the flight controller which UART you put the serial receiver on by enabling the serial RX toggle for that UART number. So for this setup, I have the receiver on UART 1. It would typically be on RX1, although some receiver types use TX instead, and that would be a topic we're not going to go into in this video. Now, there are a couple limitations here for what you can and can't do in the Ports tab. And the first thing I want to show you is you can only have one thing enabled for each UART at a time. So for example, UART 4 has MSP enabled, and now I'm going to enable Serial RX. And if I save and reboot, what you'll see is that the Ports tab is going to be completely wiped clean back to defaults. Now nothing is enabled. It's kind of disappointing that the devs do that. Like, if I create an invalid configuration, could you not just reject it? Could you not just be like, no, and put everything back how it was? Instead, it just completely wipes the whole Ports tab clean, and that's why I told you in video number 1 to back up your configuration before you start working on this, because you could get it back. So you can only have one thing at a time on each. You can't do this. One thing at a time on each row, on each UART of the Ports tab. There are a very few exceptions to this. I want to acknowledge that they do exist, but they're very, very rare, and almost always you'll just wipe your Ports tab if you try to do two things on the same UART. Now, interestingly, if I try and put Serial RX on more than one UART, it does in fact allow me to do that. However, don't get your hopes up. Betaflight only supports one serial receiver at a time. And so in a case like this, if you theoretically did wire up multiple receivers, I'm not actually even sure how you would know which one it would actually listen to. Bottom line is only enable Serial RX on one UART, whichever UART number you hooked your serial receiver to. Next, let's talk about the configuration/MSP column. MSP stands for Multi-Wii Serial Protocol, and it is a protocol that is used to talk to flight controllers going way, way, way back. The key thing you need to know about MSP is that anything that wants to interface with, to read information from the flight controller about the flight controller is going to use MSP. Anything that wants to remotely configure the flight controller is probably going to use MSP. So for example, you'll notice that this USB VCP port, which is not in fact a UART, it is the actual USB interface on the flight controller, and it has MSP enabled on it. And in fact, they won't let you turn it off because, in fact, I am using MSP right now in the configurator to talk to the flight controller over USB. And if I were to turn that off, then my whole USB port would stop working, which they used to let you do that. And then people would get locked out of their flight controllers. It's kind of dumb. I'm glad they stopped that. So why would you enable MSP for anything other than USB? The main way that MSP is used today is if you have DJI or HD0, and MSP is used by the DJI and the HD0 video systems to read information from the flight controller that they then use to draw the on-screen display. These digital video systems have to draw their own on-screen display because the analog circuitry that was traditionally used on the flight controller doesn't work with them. So instead of the flight controller drawing the on-screen display information, the HD0 and the DJI system read that information from the flight controller over MSP, and then they use that to draw the on-screen display. That's pretty much it. That's pretty much it. That's pretty much the only time you would enable MSP for any other UART other than the USB one, which is on by default. So if we look right here, we have a DJI Air unit that is connected to the JBF7 flight controller, and you can see in that plug there is a TX and an RX wire, and they're going to T2 and R2, and that is the UART connection that the DJI Air unit is going to use to read that information to draw the OSD. So if we had this flight controller right now, we would go in to the Ports tab and we would enable MSP on UART 2, and that would allow that to work. The other thing we got to know about is this pull down here, which is the baud rate, and that is how fast the flight controller will try to talk to the air unit. And the bottom line is that if the baud rate is set to the wrong value, then the communication won't occur. In almost all cases, you're just going to leave the default of 115.200. However, there sometimes is documentation for that. Sometimes you'll see them say to set it to 115.200. Next, let's go to the Peripherals column. And if we just look at what's available here in the pull down, we can go through these and discuss them one by one. And the first one is Blackbox logging. I told you in part number 1 that flight controllers have the ability to log data like a Blackbox flight recorder on an airplane, and it can be useful for troubleshooting or tuning your quadcopter. Some flight controllers have a built-in data flash chip that records that data. Some flight controllers have an SD card slot on board, and you put an SD card in them to record that data. And then if you don't have one of those on your flight controller, you can actually buy a standalone Blackbox recording module that you wire up to a UART on your flight controller, and then you can record Blackbox that way. If you were to do that, you would take the UART that you had soldered to, and you would choose Blackbox logging, and then you would set the baud rate that you were going to use. And that baud rate is going to be hopefully in the documentation for the device. Right here, it says baud rate 200,000 or whatever. The next two options in the list are VTX TBS SmartAudio and VTX IRC Tramp. These two protocols, SmartAudio and Tramp telemetry, are used to communicate between the flight controller and a video transmitter. So if you have an analog video transmitter, one of the most basic things you will do with it is tell it that you want it to be on a certain channel. And then you put your goggles on that same channel, and then you will be able to see the signal. And if you're flying with other people, a lot of times you have to move to a certain channel so that you're sort of coordinating your channels. And nobody wants to do that by like pushing a button on their video transmitter. That's annoying. Instead, you can do it using your flight controller. You can pop up a menu in your goggles, and you can use your controller sticks to move around, and you can change those settings. Looking here in the manual for the JBF7 flight controller, we can see some examples of this. Here is the iFlight Sussex Force video transmitter, and it has a wire labeled RX, and it goes to a TX pad on the flight controller. They've shown it going to T5. One thing to keep in mind is that in general, UARTs are interchangeable. So they're showing it going to T5, but there's nothing special about T5. You could put it on T4 or T3 or T2 or T1 as long as you set your ports tab up correctly. And remember, only one thing on each UART at a time. Here we've got it going to T5. Here we've got a different video transmitter, the Tramp HV, and they have labeled that wire. Instead of labeling it RX, they've labeled it T for telemetry, which is confusing, but regardless, they've got it going to UART TX. And here we've got a TBS video transmitter where they call it data, and it goes to T5. So the exact nomenclature that's used by the manufacturer of the video transmitter is going to differ. But the bottom line is when you look at a video transmitter, there's going to be a power input, there's going to be a video input, and there's going to be something that is used for the SmartAudio or the Tramp telemetry. By the way, SmartAudio and Tramp telemetry, they're two different protocols, and in general, a given video transmitter will only support one of those two protocols. And you just have to look in the documentation for the video transmitter to see whether Tramp telemetry or SmartAudio is correct. Generally, most video transmitters today use SmartAudio. It's more popular. It comes from TBS, and so all TBS video transmitters will use SmartAudio. Tramp telemetry comes from Immersion RC, so Immersion RC will use it, and I think like a few others, like I think Maytech uses it. The bottom line is you have to look in the video transmitter's product page or other documentation to see which of those is correct. So if we had wired up a video transmitter to UART 5, we would choose either TBS SmartAudio or IRC Tramp, whichever was correct for our video transmitter, here in the peripherals column, and we would save and reboot. And that's how we would set that up. By the way, baud rate is always set to auto for these two options. Next on the list is Runcam camera. This is a pretty obscure application. If you do have a camera that's compatible with this, it's pretty nice. Runcam cameras specifically support this. So if you have a Cadex or a Foxeer camera, no good. And this is just for analog Runcam cameras, as well as the Runcam split style cameras like the Runcam Hybrid. those cameras will often have a TX and an RX line that can be used to remote control the camera. On analog cameras, you can use your joystick to configure the camera options like brightness, contrast, and so forth, instead of plugging a joystick into the camera. For the Runcam split and so forth, you can actually set up switches to start and stop recording, which some people like. I've got a video more about how to set that up, but the takeaway is that if you look at the back of your camera and you see a TX and an RX wire, you can wire that up to a UART on your flight controller, and then you can remote control the camera and configure it and so forth. By the way, I don't think I've mentioned this before, but almost always when working with UARTs, TX goes to RX and RX goes to TX. That's not normally how you wire things up. Normally 5 volts goes to 5 volts and ground goes to ground and so forth. But when working with UARTs, TX on one device goes to RX on the other, RX on one device goes to TX on the other. The last two options here are even more obscure and you will almost never run into them. This LIDAR thing, I've never seen it used. I guess there's a LIDAR device out there that can talk to Betaflight. I'd be surprised if it was even still supported. I don't think you're going to run into this. And the other is OSD FrSky protocol, and there are a very, very few flight controllers, like a few of the newbie drone Tiny Whoop flight controllers use this. It is a way of communicating OSD that didn't seem to take off, but very rarely you will see a flight controller come from the manufacturer with OSD FrSky protocol set. And the takeaway for you is that if you change that, your OSD, your on-screen display, and your goggles won't work anymore. So that's all the peripherals. Next, we're going to talk about the sensor input and the telemetry column. But before we do that, if you're learning a lot and you really value this content, can I ask you to go down and hit the like button? It really helps out a lot, and I sure do appreciate it. Next, let's go to the sensor input column, and you'll see there are only two options here. The first one is GPS, and that is used if you have wired a GPS unit to your flight controller for obvious reasons. If you've done that, one takeaway is that you should usually set auto as the baud rate. If you know that your GPS unit only supports a certain baud rate, then you can set that baud rate. But if you don't know, setting it to auto, and then when we get to the configuration tab or maybe the GPS tab, I'll show you another setting for setting up GPS. But in general, you just enable this, set it to auto, and then complete the configuration in another tab. And we're going to use the ESC peripheral. When we look at our ESC's pinout diagram, let's see if I can find this. There it is. So I just picked this ESC at random, and here is the pinout diagram for the plug, and you can see that it has a telemetry pin. If we look at this other ESC that I picked at random, you can see the pinout is labeled CT, and that T is going to stand for telemetry. And here's another one just for comparison. And if we look, we can see TX. Now they've labeled it TX instead of T. The bottom line is that if your ESC has a telemetry output, it will be connected to a certain UART on the flight controller. And here in Betaflight Configurator, you would set ESC as your sensor input for that UART number. If we jump back to the manual for the JBF7 flight controller, I want you to see that here is the plug for the ESC, and in the plug for the ESC is R4. So that is where the telemetry input to the flight controller is going to be, and as the name suggests, R4, it is UART number 4. So if we were using, you're generally not going to just randomly choose a UART number to connect your ESC to. There'll be a plug built into the flight controller, and it'll have a UART number in there specifically intended for you to use it. You could solder it to another UART if you wanted to, like if you broke the plug, but in general you wouldn't do that. Now the telemetry output column, and it turns out that a lot of people aren't going to need to use this. The reason for that is a little bit lost in history, but modern protocols like Immersion RC Ghost, Tracer, Crossfire, and Express LRS, telemetry is just implied. You don't need to enable telemetry or configure telemetry with them. It's just implied that they will have telemetry. What even is telemetry? I kind of skipped that. Telemetry is the ability of the flight controller to send data back to the controller that you're holding in your hands. Some people confuse telemetry with OSD data, on-screen display, which is information you see in the goggles. But in general, the OSD data is drawn on there by the flight controller or the video transmitter and isn't really sent back to the controller. It's just displayed in the video feed. There are various reasons why you might want to send telemetry back to your controller. For example, I just like to see on my controller screen before I put my goggles on, that my battery voltage, my battery's charged up, and my signal strength from my controller is good. And then I put my goggles down and I go fly. But there are other things you can do with telemetry that we're not going to get into this video. Telemetry is not mandatory, but it is a nice to have. So it's nice that protocols like Crossfire, Tracer, Express LRS, Immersion RC Ghost all do it automatically. But some older protocols, it wasn't a given that the flight controller would send telemetry. And in those cases, you would need to manually configure the type of telemetry that the flight controller is going to send. Now, frankly, I don't want to dive into this too much because most of this is antiquated and most people aren't going to need to do this. But I would like to focus on a couple of cases that you're more likely to run into today. And one of them is FrSky SmartPort telemetry. So if you have a receiver like a FrSky RXSR, a FrSky XM Plus, or one of the newer FrSky Archer receivers, they can do SmartPort telemetry. For example, here's the manual for the Archer M Plus receiver from FrSky, and we can see it's got an S port or SmartPort pin here. That would be wired to a UART TX. It turns out that a SmartPort goes to TX. You just have to memorize these things, unfortunately. S-Bus goes to RX, SmartPort goes to TX, SmartAudio goes to TX. Eventually you will learn them if you look at enough wiring diagrams. So that SmartPort wire from the receiver would be connected to perhaps T2 here on the flight controller. And then here in the ports tab for UART2, well, we would need to disable MSP, but okay. You would select SmartPort telemetry as the telemetry output, and then that would work. And frankly, I think that's where I'm going to leave the telemetry screen because almost all of these other kinds of telemetry that are supported are pretty obscure, and I suspect that not a lot of people are going to be using them today. And in fact, that's going to bring us to the end of the Ports tab. Now you know pretty much everything you need to know to set up the Ports tab. To recap, number 1, make a list of the UARTs on your flight controller. Number 2, make a list of what peripheral is on each UART. And then number 3, go to the Ports tab and configure the settings as I showed you in this video. Next up, the Configuration tab. No, the Receiver tab. I'm going to go out of order and I'm going to go to the Receiver tab next. And if you want to know why, you will have to click that video and see. Or if you're looking to go somewhere else in this video series, there's a link to the entire playlist down in the video description. I'll see you there.